Now, how do I know? How do I know if it's going to work? Well, if I have two possible triangles, then I'm going to know an angle. I'm going to know the side length opposite is going to be 3.5 centimeters. And when I measure out from this point, if I measure out 3.5 centimeters, and this is to the perpendicular, then I could either take that same 3.5 centimeters and swing it inwards to connect with the triangle here, or I could swing it outwards to connect with the triangle here. And there are two possible points that I could connect with to create this triangle, or to create this triangle. Now, if I measured out exactly 3 centimeters from point A, and I drew it connecting over to this point, then when it's at 90 degrees, the end of it exactly touches this line, which means that it creates a right angle triangle, and there's only one triangle that can be created. When I measure out 2 centimeters from point A, then that's going to bring me out to here. And it doesn't matter how far to the right or how far to the left I swing, it's never going to connect with the other side. The measurements make it impossible for me to actually match up with the other side. Remembering that in all these cases, this was 6 centimeters, this was 6 centimeters, and this was 6 centimeters. So, if I consider the triangle in which AB was 6 centimeters and angle ABC was 30 degrees, we consider the 3 different measurements for AC and use them to determine the measure of BAC. So, if I said that AC was 2.5, then that means that I could connect it over here, or if I extend out side length A, because I don't know how long it actually is, I could use that same 2.5 and swing it out to here. So if sine C is 0.6 with a reference angle of 37 degrees, then C could either be 37 degrees, or with the same reference angle, 143 degrees. And we can see that in here. 37 degrees, 143 degrees. That would mean that angle ACB is 37 or 143. Now, how do we know that? Because sine C over C had to equal sine B, the angle we were given, over B, 2.5. Which meant that sine C, no matter what, was 3 times sine of 30 over 2.5, or 0.6. If that's true, then what is angle A? Well, angle A is either going to be 180 minus my angle B of 30 degrees minus my angle C of 37 degrees, or 113 degrees, or angle A is 180 minus 30 minus the other possibility for C, 143. My other angle A is just 7 degrees. So what is the actual angle BAC? It's either 113 or 7. We don't know. We couldn't possibly know. Now in this case, we're given 4 centimeters to draw it. Well, if I went out 4 centimeters, if I rotate inwards, it's never going to connect because that 4 centimeters is longer than the measurement I was given. So I have to swing it outwards in order to connect it. And this is only going to create this one possible triangle, where this has to be where C was because I couldn't find another C. In this case, if it's 4 centimeters, then sine of C is going to equal the 3 value of C times sine of 30 divided by my value of B, which is 4, where sine of C is going to equal 0.375. If sine of C is equal to 0.375, then the reference angle is going to be 22 degrees, which means that angle C would equal 22 degrees. Well, what if I tried to find the other possibility for this? If the reference angle was 22 degrees, the other angle that meets the same reference angle in between 90 and 180 is going to be 158 degrees. Why couldn't it be 158 degrees? Well, one of your angles is already 30 degrees. The other one can't be 158 because now you're already over 180 and it's not possible to have another measurement. So this doesn't fit into an ambiguous case, which means that if that's 22 degrees, angle BAC has to equal 180 minus 30 minus 22. The only possible angle AU could have in this case is 128 degrees. And in the last case, if I said that it was 1 centimeter long, I can extend this out as far as I want to go. I measure out 1 centimeter. It's never going to connect. If I actually tried to solve this, then I would say that sine of C is equal to 1 times sine of 30 divided by 3, which is sine C is equal to 1.5. But then, even if I try to put in my calculator, I would just stop because I can't have a sine value bigger than 1. Remember, sine is my opposite divided by my hypotenuse. To have a 1.5, it means my opposite would have to be larger than my hypotenuse, which isn't possible. The hypotenuse is the biggest angle in a triangle. Same as when we look at our unit circles. Sine goes up to 1, but it can't go bigger than 1. It just doesn't work. It doesn't make sense. So as soon as I get a sine value that's bigger than 1, it's just impossible.